Welcome in the next episode of Food Meets Science, and today we're gonna say a few words about bread and also we do some experiments. So stay with us. So everyone knows why the bread is going stale, because it's lost water. So in fresh bread, it's like soft, we can just, as you can see, squeeze it and it's really, really soft. And the stale one, it's just harder, so we need to use more power just to, as you can already see, it just putting here like drying or something like that. So it's dry, yeah? It's losing water. During this episode, we are going to check if it's all about the water's content or not. So let's treat it like a real experiment. So bread becomes stale because it loses moisture, yeah? If that's true, it's changing moisture content and it should explain everything. So let's move to the experiments. Okay, so we are going to prepare our bread for the next experiment. As you can see, we have the same two breads, yeah? And first we prepare some slices just to compare what is happening when we just leave our bread on the air and wait sometimes. So I'm gonna prepare some kind of slices here. And we are going to see if actually during the time our slice of bread will lose the water. As you can see, it's super spongy, super fresh already, yeah? And let's see how much weight the slice. It's 51 grams. And now we are going to leave it for a few days and see how much water can it lose. Now we're gonna use the second bread because I want to have two almost the same halves, because you know I'm not going to do it on the scale. So cutting to the halves, and one part we are going to put to the fridge, and let's see how much is weight. Here we have 240, I always have a problem with this number, 6 grams, okay? And the second one, 250. Okay, so we are preparing. I'm going to wrap everything and put to the fridge freezer and just leave it here. And we're gonna wait for a few days. So stay tuned and we're gonna see what is happening with our bread chemistry. So hello again, I hope that you remember our slice of bread that we showed you last time. The freshly sliced bread, it was weighed approximately 51 grams. And we left it on the air for a few days actually. We need to be honest, yeah? And let's see what's changed with this slice of bread, because we are just testing what is happening with the staling of bread, yeah? Because we think that it's make like really hard because we are losing water inside. But is it only water? Let's check how much it weighs already. And we have 33 grams, 30, so it's like free and free. Also, if you remember the slice of bread, you can see that the holes here are little bigger than previously, because we are losing some kind of water, but that not only. So we lost 20 grams of our slice of bread. It's quite a lot. But if you remember, okay, the structure is changed because this slice is like moving toward, yeah? And it's really hard and crispy that we compare with the spongy, fresh baked bread, yeah? So you can see that differences. I can just put it in and you know, it will be crushed. But it's not only about the water. As you remember, we also have two halves of bread and we put it to the different condition. This one goes to the fridge and this one goes to the freezer, yeah? And let's see what's changed and start with this bread from fridge. As you can see here, we can see different changes near to the skin of this bread, like it's a little bit darker and it's harder. here. But what about the weight? It will lose some much weight in the fridge or not? And we have 228 grams. So, not so much. We didn't lose much water in the fridge. And compared to freezer, here we have 248 grams. Also, almost nothing actually, because this half of bread from freezer was like 250. So 2 grams only. It could be a differences, you know, with the environment. Remember that we are here after 3 days, so the time also changed a little bit. And now let's talk about the cause of this, so of the starch retrogradation. So now we are going to the part why bread is going stale. When we have the freshly made bread, it's more elastic, flexible and soft. Yeah, this is why, because the bread is mostly prepared from the starch. Yeah, and the starch molecules are in freshly baked bread. They are flexible and also disorganized. Yeah, so this is why it's fluffy and quite good. But after we are just having our bread, this starch started changing the structure. So the molecules are starting to being more organized than flexible, and this is why we can observe this hard structure of the bread. It's not only because of losing water, yeah? And this more ordered, also this crystalline structure, we can call a retrogradation. So this is the chemistry process that we can find in our bread. So we change the temperature. We use the freezer and the fridge. And as you can see here, we have this effect of retrogradation. So here we have this more organized structure. As you can see here, this bread is still fresh, but a little bit stale, yeah? But this process goes really, really slower than, for example, with this slice of bread also. You can say that we have the half of bread. Yeah, here it's like the half of bread that we lose on the air, and it's actually really hard. So the process here works really, really fast. So why this bread from fridge have still actually great consistency, because we can just eat it? Because chiller temperature can slow down the reaction. So when we use the fridge, we are not stopping the retrogradation process, but we are just slowing it down. And what is happening with freezer? Yeah, we put our bread to the freezer, and as you can see, okay, it's a little bit hard because it's still partly frozen, but as you can see here, it's super fresh, and the skin is also kind of crispy. So mostly this kind of bread, it's not changing anything. And also you can see that we lost some approximately 3-4 grams, yeah, from the weight. So we can say that almost nothing happens. Why? Because we use the temperature minus 18 degrees of Celsius, yeah? So this is the temperature that stops the reaction. And when we are stopping this reaction, our starch is still disorganized and don't make this crystal structure, and this is why it's super freshly bread. We can just eat it after properly refrigeration. So let's check the myth that we have. Is it myth or not? That we have a stale bread, and we are going to use heating just to reverse this process. Probably you know that we can use the microwave and put the bread inside, and we're gonna have really spongy, fluffy bread again. So now we are gonna check it. We have stale bread, you can see that, yeah, we have this effect. It's not so fluffy as should be, and we are going to put it to the microwave, and we're gonna see what happens. So let's check it. So as you can see, we have a little bit warm, so that's good, and really flexible and fluffy slice of bread. So this heating option is working. So when we heat this bread, we use the temperature. Even you can use microwave as I used, and also you can use the oven. It will be almost the same. We just temporarily break those crystalline, and this is why we have soft and just soft bread that we can just eat it. But do you know what is happening after a few minutes? So let's wait, and we're gonna see how long this bread is gonna be fresh again.
A few moments later.
Okay, so we come back to our slice of bread from microwave, and you remember it was soft, yeah? Right now I think that you can hear it. It still goes stale like before. Because of what? Because the structures once again reforms during the cooling and the starch once again go to retrogradation process. So let's back to our claim. We have this hypothesis that we said that bread goes stale because it loses water. So is it true or not? As you can see after all experiment, it's only partially true, because it's not only about losing water in this bread, but also with this starch retrogradation and just reorganization of molecules and changing the structure. Next time when you pick up stale bread, just remember, it doesn't just dry out, it's just reorganized itself, yeah? So this is how chemistry in starch working. And once you understand that, you stop thinking of food as a static. You're gonna see that inside we still have chemistry. And using this method with temperature, so heating, freezing, cooling, you can always save your bread for wasting, yeah? Because you can just use it, reuse it after heating. You can also make some toast and everything that you can use, so not throw it, this bread away, just try to use it. So if you want to see more experiments like this, subscribe, like, and leave a comment.